So if we're looking at these now, if you notice, it's not just tan x equals square root of 3. Now it's tan 2x equals square root of 3. So it's not a case where we can divide both sides by 2 at this point. Because of order of operations, we have to get rid of the tan before we could divide by 2. So that's what we want to do. But before we do that, this over here, solve on 0 to 2 pi. So we're saying that our x has to lie between, so it has to be less than 2 pi, but greater than or equal to 0. So if I have 2x in the middle, because what we're going to do first is solve for 2x, then we're saying 2x has to lie between 0, and if I multiply the x by 2, then I got to multiply this by 2. So we're going 0 to 4 pi. So if I'm trying to solve here for tan 2x equals the square root of 3, so if I inverse tan here and I think about, well, where is tan equal to the square root of 3? Well, tan is positive, in the first and the third quadrant. So 2x equals, in quadrant 1, tan is equal to the square root of 3 at pi over 3. Now I put 2x because we haven't solved for x yet. All we're doing is inverse tan. So we're trying to say where's tan equal to the square root of 3. So 2x equals pi over 3, and in quadrant 3, that would be at 4 pi over 3. But because we're between 0, 2x has to be between 0 and 2 pi. 0 and 4 pi, we got to keep going. So I would want to be back in quadrant 1 again, so I would add 2 pi to this. So pi over 3 plus 2 pi, which is 6 pi over 3, would give me 7 pi over 3. And 4 pi over 3, if I added 6 pi over 3, we would get 10 pi over 3. Okay, so we've solved so far. We got rid of tan, but now we're still equal to 2x. So how do we get rid of the 2 in front of the x? Well, we have to go through and divide everything by 2. And since I have fractions, instead of saying divide by 2, I'm going to multiply everything by a half. So I have pi over 6. 4 pi over 3 times a half would be 2 pi over 3. 7 pi over 3 times a half would be 7 pi over 6. And 10 pi over 3 times a half, or half of that, would be 5 pi over 3. So we have to look back to our original, and we said originally that our x had to lie between 0 and 2 pi. And if you notice, all of these answers are between 0 and 2 pi. So let's look at this one. Now we have sine of x over 3 equals 1/2. So we're thinking about here that we want x to be less than 2 pi, but greater than or equal to 0. So if I change this to x over 3 in the middle, then on these, I have to do the same thing. So I have to divide by the 3. So here, if I divide by 3, I still get 0. Okay, so we're thinking about sine. So here we have x over 3 equals 1/2. So think about, where does sine equal to a half? Sine is equal to a half at pi over 6. And sine is equal to a half in quadrant 2 at 5 pi over 6, right? So if I now, to get rid of this, because I'm trying to solve for x equals, if I multiply by 3, we get pi over 2. And if I multiply this by 3, we get 5 pi over 2. So now we have to think back to the original. X, our answer, had to be between 0 and 2 pi. So pi over 2 is less than 2 pi, so that one's good. 5 pi over 2 is 1.5 pi, so this is not a good solution. This is 2.5 pi, and I could only be less than 2 pi. So this one is not good, which means our only solution was pi over 2. Now we could have gotten that because when we were solving for x over 3, we shouldn't have gone past 2 pi over 3. But y'all are just so good with fractions that I slipped that in there. 5 pi over 6 is bigger than 2 pi over 3, so we never should have put that one in the first place. But if you went ahead and did that, as long as you look back at your original and say, well, I was supposed to be between 0 and 2 pi, and this answer is bigger than 2 pi, so I can't have that solution. So